In this video, we would like to introduce an industry audience expansion system that has been deployed at Alipay. Since Alipay is now serving more than 1 billion users, how to efficiently deliver financial products or service to the right users is of significant importance. In order to promote mobile products or service, companies like and financial conduct thousands of marketing campaigns every day. One of the fundamental issues of running marketing campaigns is the audience expansion problem. Given a campaign with a certain promotion goal, as well as a set of seed users, the task of audience expansion is to target more users who are similar to the seeds and are interested in the products or service promoted by the given campaign. The seeds may be generated in different ways. For example, selected by experts, retrieved according to the past relevant campaigns, and so on. And the seeds are aimed to get the expansion. High quality expanded audience will benefit the conversion population while reducing the operating cost. In real-world marketing scenario, existing audience expansion techniques suffer from several challenges. We summarize the following 3 points. First, it's about scalability. Take Ant Financial as an example. In order to promote the mobile financial service like Ant Insurance, Ant Credit, Ant Cash, and so on, the marketing system needs to run about 200 campaigns toward 1 billion users every day. Training an end-to-end model for each campaign is extremely resource-consuming and impractical. In this paper, we adopt an online-offline two-stage approach. Second, one major issue of a two-stage approach is the quality of user representation. Existing approach neglects 2 crucial issues toward better user representation. The former is the high-order interactive information between users and campaigns. The latter is the entanglement of the user embeddings. In Ant Financial, the campaigns fall into different domains. For example, payment service, insurance, wealth management, movies, and local service, and so on. A user can interact with campaigns from different domains for different reasons. Hence, a high-quality user embedding should have the ability to recognize and disentangle the heterogeneous latent aspects. Third, the courage bias induced by the seeds. In the setting of audience expansion, a set of seed users is given to get the expansion process. In the previous literature, the seeds are usually treated as passive examples of a classifier to distinguish seeds and other users. In practice, the seeds are generated in different ways. For example, provided by experts, collected from some past similar campaigns, or collected from users' feedbacks during the target campaign is running. Such a guidance usually induces bias with respect to actual audience because of various reasons. For example, the seeds given by the experts could be noisy. The past similar campaigns could be different from the target one in some aspects. The feedbacks collected from the target campaign cannot characterize the whole demographics at the very beginning of the promotion. In this paper, the term coverage bias is used to denote the gap between the seeds and the ground truth audience. To our best knowledge, this is the first work to address this challenge in the audience expansion problem. Okay, our Hubble system follows a hybrid online-offline architecture to satisfy the requirements of efficiency and effectiveness. That is, we propose a two-stage framework, which includes an offline representation learning stage and an online audience expansion stage. In the offline stage, we propose a novel adaptive and disentangled graph neural network called ADGNN to adaptively explore the user campaign graph and generate comprehensive user embeddings in a disentangled manner. Basically, we construct a huge graph describing historical user campaign interactions and generate and maintain a storage of user and campaign embeddings. The embeddings are asynchronously updated per week, and they are used as features for audience expansion tasks. In the online stage, to alleviate the coverage bias issue, we develop an audience expansion model with knowledge distillation mechanism after receiving a request from campaign system. On the basis of the seeds included in the request, we propose a knowledge distillation-based lightweight model called KDAE to rank all the potential users. Finally, the system returns the top K users to the campaign system. Thanks to the hybrid on-offline stage, two-stage architecture, Hubble system is able to finish an audience expansion task in several minutes and still outperform the state-of-the-art end-to-end approach, which can take hours. Okay, in the following, we will discuss the core components in Hubble system, that is offline ADGNN and online KDAE. We will show the experimental results and conclude at last. The offline module of our proposal contains a graph constructor and an ADGNN model. The graph constructor collects the input historical user campaign graph and then updates this user campaign graph weekly. The ADGNN model is responsible for generating high-quality user embeddings that represent users' heterogeneous intention toward different campaigns. To achieve this goal, we formalize the learning objective of ADGNN in a link prediction setting to model whether a link exists between a user and campaign or not. Considering the fact that a user may connect with different campaigns for different reasons, we employ a disentangle mechanism in ADGNN to disentangle user embeddings into several channels with respect to their heterogeneous intentions toward different campaigns. Moreover, we refine the disentangle mechanism by incorporating an adaptive breadth function which enables to eliminate some noisy neighbors because of causal user campaign interactions. ADGNN mainly consists of three steps. First, the projection of each node to K latent subspace. Second, neighbor routing to generate disentangled embeddings. Third, adaptive breadth function to filter noisy edges. Our method first projects each node feature vectors into K different subspace. We denote the projection in the K subspace or K's channel of node I as Zik. Here we denote Xi as the raw feature of node I. W and B are parameters. Should be learned. After the projection, we do neighbor routing iteratively to construct the disentangled embedding H of user U in K's channel. It starts by initializing H of U as projection Z of U. Then, iteratively measure the similarity between target node U and its neighbors V. Then, we update H of U by averaging its neighbors' projections. After several iterations, each node U user will find a stable point in each K's channel. The above disentangled mechanism neglects that there could be noisy edges due to, for example, cultural conversions between users and campaigns. To address this problem, we refine the disentangle mechanism by incorporating an adaptive breadth function to enhance the propagation along important edges so that to eliminate the noise. Such an adaptive and disentangle layer can be stacked L times, iteratively to capture information of L hops neighborhood and generate the final disentangled embeddings. Our second component, the knowledge distillation based online model called KDAE, is responsible for performing audience expansion given any new campaign. Note that the only information about new campaign is the set of seed users. The task is to take seed as input and to find out a much larger expanded user set, in which the users are similar to the seeds and have potential to convert when the new campaign is released. Conventional audience expansion techniques suggest to train a classifier with positive seed and negative random selected. Such methodology neglects the fact that the seeds are usually biased, thus fails to cover the ground truth audience demographics. The figure on the right shows the existence of coverage bias in real world. The distribution of the seeds in red cycle can not cover the distribution of the ground truth audience in blue triangle. Note that we draw this 2D figure using t-SNE from embeddings of seed and ground truth audience. To eliminate such coverage bias, we resort to offline ADGN model, which has learned knowledge from all historical interactions between users and the past campaigns. Inspired by knowledge distillation mechanism, we employ such a teacher-student style in KDAE to absorb knowledge from the teacher model ADGN and to get the training of student audience expansion model. KDAE mainly consists of two steps. First, generate training samples include hard and soft labels. Second, train a multi-layer perceptron model for ranking. The connection between a teacher model and a student model is the soft labels predicted by the teacher model. However, most upcoming campaigns are brand new in our scenario. Thus, it's hard for ADGN to make predictions for the users with respect to a new campaign. Though ADGN is unavailable to directly predict for a new campaign, denoted as C, there still exists a certain amount of past campaigns which are similar to C. If we find out these similar past campaigns, the soft labels for a certain user could be constructed based on the estimates of ADGN on those similar campaigns. We clustering the seed users into K clusters. We denote the centroid of each cluster as H of Ci. We use those centroids as top K most similar historical campaigns to this brand new campaign. Then we can calculate the soft labels as the equation on right. That is, we first measure the distance of user U to each of K historical campaigns, then transform by sigmoid, and finally average over all K campaigns. Given the hard labels and the soft labels in the online stage, we simply build a two-layer perceptron for optimizing the cross entropy. We employ the real-world industry data from Alipay to evaluate our approach. Specifically, for the offline task, we randomly select a portion of users as well as their interactive campaigns. All the interactions occur in 1 week in January 2020. The former 70% of them along the timeline are used to construct the user campaign graph, while the rest is used to build the training and validation sets. For the online audience expansion task, we select 3 campaigns, namely payment service, travel, and fund service, which are conducted in the next week. The seed users, ground truth audience, and candidate users of the 3 selected campaigns are collected for evaluating these 3 audience expansion tasks. In this slide, we analyze the end-to-end performance of audience expansion task for all comparison methods by treating the actual audience as positive samples while other candidate users as negative. We show the AUC values in the table. Our proposed Hubble system outperforms other audience expansion methods in all 3 tasks. On one hand, the offline part of Hubble system utilizes ADGN to describe users in a more comprehensive way. On the other hand, the online part employs KDD to alleviate the coverage bias introduced by seeds, while other methods fail. By combining these 2 advantages altogether, Hubble system achieves the best performance compared with both end-to-end classifiers and 2-stage methods. In these slides, we analyze the performance of link prediction to evaluate the quality of representation learning. We employ 2 actual public data sets, that is Taobao and Tmall. We treat their items as campaigns. Similarly, for the 2 data sets, we separate the interactions into 2 parts regarding their timeline. Our proposed ADGM achieves the best performance among all comparison methods on 3 data sets. In this paper, we propose the Hubble system for audience expansion at industry. To better balance effectiveness and efficiency, our proposal employs 2 stages: offline representation learning and online audience expansion. At the offline stage, we propose ADGN to adeptly explore the historical user campaign graph and generate high-quality user embeddings. At the online stage, we propose a KDD model, which employs a knowledge distillation mechanism to absorb knowledge from ADGN to eliminate the coverage bias introduced by the given seed users. By combining these 2-stage Hubble system demonstrates its superior effectiveness and efficiency in both offline experiments and online A/B testing. The Hubble system has been deployed in the production environment of Alipay to serve billion users. Thank you for your attention.